Okay, today we're diving into a really interesting document. It's one that tries to apply hard digital forensics to a pretty unusual phenomenon, these strange faces that just mysteriously show up in photographs. Now, this isn't about ghosts in the classic sense. It's about what the source document calls a ghost in the machine, a signal that might just have its own unique digital fingerprint. So, take a look at this. At first glance, it just looks like a weird, distorted image, right? But according to the paper we're looking at, we're actually seeing two completely different things here. One is a regular photograph of a real physical person. The other, the other is something else entirely, something this document claims is a non-physical overlay. The real question is, can you tell which is which just by looking? And that really gets to the heart of this whole analysis. Can we go deeper than what our eyes see? Is there some kind of hidden technical signature, a digital fingerprint, that could definitively separate one from the other? This document claims there is, so let's take a look at the evidence they present. First step, the digital fingerprint. You know, before you can find something, you have to know what you're looking for. So the first thing the analysis had to do was define the phenomenon and set a really clear objective. The key term here is transimage. The document is very clear. This isn't a reflection, it's not a camera glitch or some kind of artifact. They define it as a type of visual interference. The whole idea is that these are not photos of physical things, but projected overlays sent from, and this is a direct quote, an extracorporeal intelligence. So the mission becomes pretty straightforward. Figure out if a transimage is fundamentally different from a normal photograph at the raw data level. The ultimate goal here is to find a consistent, measurable digital signature that could, once and for all, tell them apart. All right, so let's get into the first case file. This one takes a close look at that first image we saw, where you have a suspected transimage laid directly over a real photo. This is perfect because it gives them a control sample right there in the very same frame. The first test they ran was an analysis of the image's tonal depth. They used a tool called a histogram. All that does is it basically counts the pixels at every level of brightness, from pure black all the way to pure white. It gives you a clear profile of all the light and shadow in an image. Now, this is where it gets really interesting. Here's a direct comparison. On the left, you've got the histogram for the real face, and on the right, the histogram for the transimage. I mean, you don't have to be a tech expert to see right away that the shapes of these two graphs are completely different. So here's the key takeaway, according to the analysis. The histogram for the real face is all bunched up in the darker tones on the left. That's pretty typical for a photo that has natural shadows and real physical depth. But the transimage? Its curve is way broader, much flatter. The document interprets this as a huge red flag for artificiality, a sign that it's missing true tonal depth. Okay, the next test goes even deeper. They use something called a fast Fourier transform, or FFT, to look at the image's frequency spectrum. Now, don't let the name scare you. To put it simply, this technique just breaks an image down into its finest details and textures versus its smooth, flat areas. And here are the results. Again, the visual difference is just striking. The image on the left, from the real face, shows this really complex, spread-out pattern. The one on the right, from the transimage, looks a lot smoother and much more concentrated in the center. So the interpretation here is that the complex pattern from the real face, with all those high-frequency points, represents all the rich textures you'd expect: skin, hair, the way light hits a physical object. By contrast, the smoother pattern of the transimage suggests it just has fewer fine details, which is totally consistent with the idea of it being a simpler, projected visual. Okay, now the analysis really ups the ante with a second, more complex case. This time, it's not an overlay. We're looking at three distinct faces that all appeared in the same video frame. Here's the source image for that. The analysis identifies face 1 and face 3 as real people. But face 2, the one right in the middle, that's the suspected transimage. This setup is great because it allows for a comparison between two known subjects and the one anomaly. So before they even got into the really deep analysis, they stumbled on a fascinating little finding. They ran this image through standard facial recognition software, the kind that's designed to find the specific patterns of a human face. It correctly identified face 1 and face 3, no problem, but it completely failed to detect face 2 as a face at all. This leads us to the next test, which measures something called local entropy. The easiest way to think about entropy is as a measure of data complexity, or how much information is packed into an image. A really detailed, textured picture has high entropy, while a smooth, uniform one has low entropy. And wow, this visual really illustrates the difference perfectly. These are the entropy maps for all three faces. The brighter the area, the higher the data complexity. You can immediately see the maps for face 1 and face 3 are just rich with all these varied patterns. But the map for face 2, the transimage, is visibly darker and much more uniform. So the conclusion from the document is that the real faces contain the amount of rich, visual information you would expect. The transimage, on the other hand, is what you might call information poor by comparison. This lack of data density really supports the theory that it isn't a picture of a complex physical object, but maybe something like a non-dense projection. The final test in this particular case file takes a look at the light and shadow profiles. By plotting the average light intensity across both the horizontal and vertical axes of each face, the analysis can compare exactly how light is behaving across their surfaces. And just look at these graphs. The pink and orange lines, which represent the real faces, have these relatively smooth, organic-looking curves. But the yellow line for the transimage is completely different. It's jagged with these sharp, almost unnatural-looking spikes and dips. So the interpretation is that the smooth curves of the real faces show how light naturally falls on a three-dimensional object that has depth and contour. That jagged profile of the transimage, though, it just doesn't seem to reflect the physics of light on a physical surface. Instead, the document suggests it looks a lot more like digital interference, or maybe even a modulated signal of some kind. So after running all of these tests across both case files, analyzing everything from tonal depth and frequency to entropy and light profiles, the document arrives at a pretty startling conclusion. Based on all these consistent patterns, the lower complexity, the artificial light profiles, the analysis concludes that these transimages do have a unique digital signature. They argue this supports the hypothesis that these images are not physical objects, but a projected transmission. And then it goes one step further, proposing an origin, a transmission station beyond the dense reality. So, what do we do with all this? The document presents a whole series of digital forensic tests that seem to show consistent, measurable differences between ordinary photos and these things they call transimages. The data leads its authors to an absolutely extraordinary conclusion, leaving us with the ultimate question: are we looking at the first empirical evidence of another reality communicating visually, or is this just a highly sophisticated, technical analysis of our brain's tendency to find patterns in noise, a fascinating new chapter in digital pareidolia? The data is right there on the screen. The conclusion? Well, that's yours to consider.